Hi, it's Tom. We have a remnant of a prairie that runs alongside the research station right in front of me here, and I wanted to use this as an example of heritability, and in particular take a look at some of these prairie grasses. What if, for instance, I wanted to do some selection on these prairie grasses and perhaps try to find some that might be domesticated and become kind of interesting new varieties that people would use in their garden. Well, if I'm going to do that, I'm going to have to select some of these plants with the hopes that they are going to be particularly good. And I might select them on the basis of something like height. So here's a plant that's tall, and here's a plant that's shorter, and here's one that's kind of in between. Let's say I do selection for those and I keep the plants separately. So I harvest the seed from the tall plant, keep it separate from the seed from a short plant, and keep that separate from the medium. And I do that for lots of plants. And then next year I plant out those seeds out in the field over here and I see how they grow up. And let's say that this is where I planted them, even though it's not. And my tall seeds result in some plants that are short, some that are tall, some that are medium. My plants that were short result in some short plants and some tall plants as well. And what I'm getting at is that I select based on a certain height. The parents that I chose were a certain height, like tall ones, but at the end of the day, they ended up not being tall. The tall parents didn't result in tall offspring, and the short parents didn't result in short offspring. They all tended, regardless of what I selected, the offspring were all over the map. That's a case of very low heritability. The offspring and the parent didn't resemble each other. And it's a result of, in that equation of phenotype equals genotypeless environment, it's a case where the environment is very high and really influencing the way the plants look much more than the genotype. On the other hand, if when I selected for tall plants, all of the progeny were tall, and if I selected for short plants like these guys, all of the progeny were short, then that's a case of high heritability. And in that case, the effect of the genotype was much larger than the effect of the environment. And so I'm going to show you that example inside. You know what? I really dislike heavy metal music. And the reason that I bring that up is while I was outside, I'm pointing out my window, while I was outside filming that segment on the prairie grasses, some dude drives up into the parking lot right next to me, turns his heavy metal on full blast, who's driving me nuts. And I think that's exactly why it continues to be popular year after year after year, as it drives parents crazy. I'll take rap any day. Anyway, I'm done ranting. What I want to show you is what happens when we have offspring that look like parents versus offspring that don't look like parents. It's a question of heritability. And the way that we show this is using something called parent-offspring regression. I like figures way better than tables because once you get a sense of them, you can see what's going on, and it explains it in a very compact and rich way. All right, so with parent-offspring regression, we have, for instance, the height of parent plants. So I'll put parent height. And on the y-axis, we have offspring height. And so this is the short end of the scale. And this will be tall up here, so kind of a relative scale. And this will be short offspring, and this will be tall offspring. All right, so the first example that I had was when I was talking out there, being annoyed by the heavy metal, was of a situation where you selected tall plants and grew them out, and some of the offspring were short, and some were tall, and some were medium. And in that case, the points on this graph that would correspond to that would be like this. Let's say we had tall plants, so that's here in the parents, but the offspring were both short, medium, and tall. So tall plants had some short, some medium, some tall offspring, They were scattered all over here. And we had some short plants that we also selected, and they had offspring that were tall, medium, and short too. So short parents had some short, some medium, some tall. So they were all over the place too. And then we selected some medium and the same story, all over the place. Well, with data points like this scattered all over, there's no sort of single line that you can draw that is a line of best fit, as it's called, a good regression line. There's really no correspondence between offspring and parents, and that's a situation of essentially zero heritability, where the parents don't resemble the offspring at all. In that case, it's usually the case that the environment in this phenotype equals genotype plus environment type of equation, it means that's very strong in determining phenotype rather than genotype. And so when you're selecting something on the basis of how it looks because of the environment, next year when you grow the seed out, they're not going to look anything like the parent. Like the example I had in the lesson, where if you select a plant because it's tall and you don't know it, but it's growing on a very fertile part of land because it's on some manure, you're going to select that plant and think it's great. And then you grow it next year and it's growing in just usual soil and it's kind of mediocre. So that's a situation where environment has a really strong influence. But what if the second scenario, where you select tall plants and you grow their progeny, and the progeny are also tall, and so your points are up here somewhere. And you take a look at medium-sized parents, and their offspring tend to be medium-sized. And then you look at some short parents, and their progeny tend to be short. Now, you can draw a line that connects these three groups of plants very nicely. It fits pretty well. Compared to that mess that we had before, this looks nice and organized. When you can draw a line like this, it means that you have a much higher heritability. It means that if you select tall parents, then your offspring are likely to be tall. And again, going back to phenotype equals genotype plus environment, what it means is that the genotypic influence is very strong and the environment is rather small. So when you're selecting plants, it's on the basis of good genes rather than growing on a hunk of manure. And so if it's on the basis of good genes, then your offspring are more likely to look like your parents. So this is called parent-offspring regression. Parent-offspring regression. And it's a way of looking at heritability. And just as a detail, heritability has values that run from 0, which is no heritability, up to 1.0, which is the highest heritability possible. And so it's always in the range of 0 to 1.